Yeah, hi everyone. Today we're giving a little input on the psychological perspective of human oversight of artificial intelligence. Who are we? My name is Markus Langer. I'm professor of work and organizational psychology at the University of Freiburg, and this is my colleague.
Linda Onnasch. I'm a professor of psychology of action and automation at the Technische Universität Berlin.
As you see, we are part of many associations, appointed members, and leaders involved in different important associations internationally and in Germany on human AI interaction.
So the aim of this short presentation is to illustrate the relevance of psychological expertise in the debate on the European AI Act. If we look at the AI Act, we find something remarkable. It is suddenly not about AI, but about humans. And Article 14 is about meaningful human oversight of AI when it is used in so-called high-risk areas such as medicine, aviation, or personal selection. In these cases where humans work together with AI, we are talking about socio-technical systems that need to be designed, not just the AI alone. And the aim of human oversight, as set out in Article 14, is to minimize the risk posed by the use of AI systems. So this article contains statements such as the human should prevent or minimize the risks to health, safety, or fundamental rights of humans. The human should also properly monitor the AI system and understand its capabilities and limitations. The human should also, when supervising or monitoring the system, remain aware of the possible tendency of automatically over-relying on the output produced by the AI system. So this is about automation bias, a cognitive bias we see when people interact with highly reliable technical systems. And the humans should also correctly interpret AI output and decide to use or also to disregard AI and come to independent own decisions. Now, these are incredibly high demands on human oversight, almost giving the impression that an omniscient human is needed to fulfill these requirements and fulfill this role. What this excerpt shows above all, however, is also that the legal regulations on AI involve key psychological concepts and that an effective implementation, design, and testing of AI requires psychological expertise.
And what I hope that this talk will give you is that it gives you two triangles that you will always remember from now on. And these two triangles, they define what we understand of the concept of human oversight and how can we really design effective human oversight. This is the first triangle. You can find it also in one of our publications that you see on the left side. And it tells basically the story that effective human oversight depends on humans being in actual control of AI-based systems. What does control mean? Article 14 of the AI Act basically says there should be a stop button that humans can always use to stop the AI. That is control of AI, but there are many, many more ideas of how you could control AI. It's the basic idea that humans are always in the steering, they have the steering wheel, they can really end it, they can override outputs of AI, they have some effective control of what is happening. But control without understanding is worth nothing, actually. So understanding in this top square, that means basically that people have to have some kind of understanding of what the AI is doing. They have to understand the processes behind the AI. They have to understand how the AI comes to its outputs. And without this understanding, it's probably not so incredibly meaningful to control what is happening here. But also without control, it doesn't matter if you understand anything. You can understand what you want. If you cannot stop it, if you cannot override what is happening, then this understanding is worth nothing. And the third part of that triangle is what we call motivation. We also need a human oversight person that is motivated to actually oversee such a system. I think it's probably easy to imagine how incredibly boring it could be to oversee such an AI-based system. It works quite well all of the time. You just sit there and look at it, and you don't really know why you are there. This can really undermine human motivation, and I think we all know what happens when humans are bored. I think they will not produce effective human oversight anymore. And you can't look at one side of that triangle, of one corner of that triangle, without looking at the other corners. And the same applies here. This is basically the three corners of this triangle that tell us how can we now design effective human oversight? How can we get this control? How can we get this understanding and this motivation that is required for effective human oversight? We can design the technical factors. We can really change how the AI is designed. We can add explainability mechanisms. We can adapt the interface or the interaction design. We can look at individual factors, so at the human factors in a way. We can prepare the humans. We can look at their needs and goals. We can implement training sessions for them. Or we can look into the environmental factors that affect the human AI interaction. Is there time pressure? You can imagine if you have 200 unread emails in your email account, and at the same time you're supposed to oversee an AI-based system. These are things that conflict with each other, and they also have to do with this concept of effective human oversight. And again, you cannot design one of those corners of the triangle without affecting the other.
So what are the challenges in the human oversight of AI? So let's dive a little bit into detail here. A very central question here is how to avoid cognitive biases in decision-making. So this is about the use of AI as assistance systems or support systems, for example, in medical diagnostics. And in such cases, the lack of transparency of AI actually always implies decisions under uncertainty. So that factors other than the pure information can become decisive here, such as, for example, trust in the AI. In addition, the use of AI as a decision support system itself represents a decision problem. In addition to the original decision situation, I now also have to decide whether to follow the AI recommendation or not. In other words, in the attempt to simplify the situation through AI support, we concurrently increase the complexity. Another question that arises is, what are the prerequisites for humans to adequately understand capabilities and limitations of high-risk AI systems and properly monitor operations? Due to the inherent lack of transparency of AI systems, we need to think about ways in which we can still enable people to make appropriate judgments about how the AI works. In this context, for example, the question arises as how to explainable AI must be designed, and what explanations do humans actually need in order to be able to act. Or another question that arises here is how interfaces should be designed in this context so that they become very intuitive and easy to understand for the human operator.
And further challenges arise from the fact that the AI regulation or the AI Act really requires effective human oversight, not only to minimize safety or health risks, but also risks to fundamental human rights. So for instance, human oversight should recognize discrimination or a lack of fairness in AI-based outputs. We all know AI-based outputs can produce unfair outputs, can produce what some would call discrimination. But when and how should human oversight persons actually decide that something is unfair? It is much easier to say that an AI did not detect a tree or it did not detect a broken bone in a medical image. But saying that an AI system has produced an unfair output, this is really challenging. Some people would only say that very obvious discrimination and unfair outputs are problematic. Others would say the slightest idea of unfair outputs is already problematic. It's very challenging to design human oversight that in this effect can be effective. And also very big challenge is actually how do we ensure that we are compliant as companies with the requirements of the Article 14 of the AI Act. We could imagine in the future some checklist-based approaches where you just have a checklist and the checklist says, do your human oversight persons, do they understand the AI? Do they know the limitations? Check. Do they have automation bias or do they not have automation bias? Check. This sounds like very low bars to pass. This will probably not make anything better than before. And in the other extreme, we could imagine a situation in the future where every single combination of human AI collaboration has to be empirically tested. So you change the system, and as soon as you change the system, you have to show empirically that the human oversight is actually effective. This is probably also not a good solution because it involves an incredible amount of work. So what could be a solution? We imagine what could help is that what you're doing, your human oversight design and process, is compliant with the current state of research on the effectiveness of human oversight. But this current state of research, it comes from human factors, it comes from psychology, it comes from human-computer interaction research. And this is very central to integrate this expertise into the picture. And this is why this is the last slide with the picture that we also want you to remember of the necessary expertise for the design of effective human oversight. It's very clear that we need computer scientists to design the technology. It's also very clear that we need legal experts, law experts, we need ethicists to say, okay, is this what we're doing here actually legally compliant? But in the end, we also need psychologists. We need human factors, human-computer interaction expertise that tells us, is what we're doing actually effective from the human perspective, from the socio-technical perspective? Because if we say we are designing human-centered AI, we should definitely also involve people who know something about those humans, who have expertise about those humans. So thanks for your attention.
Thank you very much.